Welcome all of you to the electric neuron. Today we are going to see about the mesh analysis in network theory, which are very important to your examination like GATE, ESC, sscje, RRBJ. In the previous lectures we have already discussed about the source transformation and dependent independent voltage source and current source. So why it will be used we have already discussed. In this lectures we are going to see the mesh analysis, why it will be used in the network theory and how it will be implemented in the network theory. Okay, so before starting our video lectures I want to tell you that if you like the video then please share to your friend and also subscribe to this channel so that you will get immediate notification whenever I will upload a new video. Okay, so keep watching this video. Now start. See, this is the mesh analysis. So why we use the mesh analysis? See, our electrical network that is very complex in nature. So many resistance, inductance, capacitance are connected to a looped network, and those are very complex in nature. So for solving this complex problem we need this mesh analysis one also. Okay, so see, this mesh analysis is a loop. It does not consisting of any inner loop. Okay, so mesh analysis does not contain any inner loop. So first we need to know about the loop. What is loop? So if a closed path is there, then it is called a loop. Okay, so if we see this figure, this is the one closed path, so we can say this is our one loop. Okay, and this is another loop, this is another loop, this is another loop. But here see, the first sidewise connection or this rectangular, big rectangular is also another loop, and this rectangular, this is also our another loop, this is also our another loop. Okay, those are one loop. Now see, when the network is drawn in a plane without any crossover turn, okay, without any crossover turn, see, in this loop there is a crossover. See, this is our big loop. Okay, so there is two crossover. So this is one crossover, this is another crossover. So it is not our mesh. You see, it is loop. This is also loop, this is also loop, but this is our big loop. But if we say about the what? Mesh, then mesh does not contain any loop, any crossover. So this is also one mesh, this is also mesh, and this is also mesh, this is also another mesh. So here no crossover is there, so that is also called our mesh. Okay, this is the planar network, and this is also planar network. But this is our not planar network. This is non-planar network. Why? Because it is one crossover in the network. See, this is first network. In the first network there is another network is crossover to each other, means they are overlap in each other. Okay, so that's why it is a non-planar network. But here no overlapping is there, so that's why it is not non-planar, it is a planar network. Okay, so mesh analysis only applicable for planar network, not applicable for non-planar network. Okay, please remember that. And mesh analysis can be applied only for the planar network. I have already told you that. Now, okay, so now see the procedure of mesh analysis. So how it will be implement in the network, and how we find the current across the mesh network, we'll see the procedure. So first point is identify total number of mesh in the given network. See, I am taking this previous network only. Here there is mesh 1, this is also mesh 1, this is another mesh 1, this is another mesh 1, and this is another mesh. Okay, so there is 4 mesh in this network. Okay, this is planar network, and assign the current direction for each mesh. So if you want to apply clockwise, then it is also okay, or if you want to apply the anti-clockwise direction, this is also okay. Okay, right? Now see the third point, that is develop KVL equation for each mesh. So after applying the current direction here, we need to apply the KVL equation. We have already discussed the KVL formula, the summation of all the voltage meeting at a point or any loop equal to 0. So apply KVL formula in this mesh. Then by solving the KVL equation, find loop current. So after applying the KVL equation, we need to find the loop current. Okay, so this is the full procedure of mesh analysis. Now see one question regarding the mesh analysis. There is a 4 voltage connected with one resistance, and there is a one current sources with 2 ampere its value, and the resistance connected with that current sources, that is 10 ohm, and in between the current sources and voltage sources there is 2 ohm resistance connected in parallel manner. So here what we will do, we need to find the current I1 and I2. See, there is a 2 loop, a 3 loop. See, this is one loop, and this is one loop, and this is another big loop. So here 2 mesh will be formed. This is the one mesh and this is the another mesh. Two mesh, that mean 2 equation will be formed there. Okay, so see the first equation by applying the KVL only, that is Kirchhoff's voltage law only. It is 4 voltage, it is going from there to there. Okay, so minus 4 voltage, then here I1 amount of current will be flowing across there, so I1 into 1. Okay, I1 into 1, then I1 into 2. Okay, so this loop is completed, and another I2 current will flow from this side to this side. Okay, so that's why minus of 2 I2 here. Okay, so this is the equation number 1. After calculating this equation only, 4 and 2 plus 1, that is 3 I1, and this is minus 2 I2 equal to 0. Okay, so you can also write the equation, that is like this: minus of 4 plus this I1 into 1 plus 2 into I1 minus I2. Okay, why? Because of this current will be flowing like this clockwise, and this current will be flowing like this, lower side to upper side. Okay, that's why I1 minus I2. So here in this loop there is one current I2, that I2 will be flowing like this, but this current will be flowing like this. So I2 is equal to minus of 2 ampere, because of it is opposite direction to the I2. So that's why I2 is equal to minus 2. So now put here in this equation number 1, put the I2 value, that is minus of 2. So minus of 2 into minus of 2, that is minus of 4 plus 4. Okay, so plus 4 and minus 4 will cancel each other. Then 3 I1 is equal to 0. So 3 I1 is equal to 0 here, and I1 is equal to 0. So I2 is equal to minus 2 and I1 is equal to 0. So both the I1 and I2 current will be found from this mesh analysis by applying this procedure only. First, what we will do, we will identify the mesh, what are the how many number of mesh is there. So there is 2 mesh. After that, assign the current direction. So we assign the current direction in clockwise direction only. So after that, develop KVL equation for each mesh. So we have applied the KVL equation here, and then we will get the equation number 1, then a KVL equation here, then we will get the equation number 2 here. This is our equation number 2. So by solving the KVL equation, find loop current. So by applying this I2 value here, then we will get I1 value. So loop current will be founded here. Okay, now see, this is the one important term in the mesh analysis, which is very important to write any exam in your electrical. See, in mesh analysis, total number of equation is equal to total number of meshes. So I have already told you that there is 2 mesh, so there is 2 equations. This is equation number 1 and this is equation number 2. So there is, please remember this term, in mesh analysis, total number of equation is equal to total number of meshes. So E is our equation, M is our meshes. Okay. So in this there is 2 meshes, that means 2 equation is there. Okay. So now see, or equation is equal to B minus N minus 1 in bracket. Okay. So what is B? B is your total number of branches, and what is N? N is your total number of node. So B, see here, there is 3 branches. This is one branches, and this is another branches, and this is another branches. Okay, so there is 3 branches. So put here 3 branches, and node, number of node. See, this is the another node N1 and another node N2. So there is 2 node in this network. Okay, so put here 2 minus of 1. So after calculating this, 3 minus 2 minus 1, that is 1. So 3 minus 1 is equal to 2. Okay, so our equation will be 2. From that only we will find the equation number 2, and by using this equation also we can find the equation. Okay, so let's see the another point. In the above network, to find the loop current, minimum 1 equation will be required. Okay, so to find the loop current, minimum 1 equation will be required in the mesh analysis. Please remember that point also. Okay, now see another problem. See, this is the 10 volt sources with 1 ohm resistance connected with the another 1 ohm resistance parallel with the 1 ampere, and 1 ohm resistance with the parallel 2 ampere, and another 1 ohm resistance with 3 ampere, and the anti-clockwise like this. This is clockwise, this is anti-clockwise. Okay, so here it is asking about to find the current I for the network sum. So we need to find the value of current I here. Okay, by applying this KVL equation only. So there is one loop or one mesh is there. So we need to apply one KVL equation here. Okay, so by applying the Kirchhoff's voltage law only, see, this is flowing like this in clockwise direction. So 10 voltage is there, so put here minus of 10 because of the sign convention only. So it is going minus to plus, that's why we are taking here minus term. Okay, so minus 10 plus, see, 1 ohm, there is 1 ohm, there is another 1 ohm, there is another 1 ohm connected in series manner. So 1 plus 1 plus 1 plus 1, that is 4 into I1. Okay, I1 amount of current will be flowing like this. So that's why 1 into 4 into I1. And here, see, this is another current flowing in same direction. See, it is flowing in that direction only, and I1 also flowing in that direction only. So it is in same direction. Okay, so that's why we are taking here positive signs. So I1 into 1 ohm, or I1 is equal to how much? 1 ampere. So 1 into 1 is 1, minus of 2 into 1. How? Because of this current equation, this is flowing like this. So this current will be like this, and our main current will be flowing like this. So it is opposite direction, that's why we are taking minus here. Okay, so minus of 2 into 1 ohm resistance, and here this is flowing like this, and our main current flowing like this. Okay, so both the current direction are same, that's why we are taking positive here. And 3 into 1, so 3 into 1 is 3. Okay, so after calculating this, we will get minus of 10 plus for I1 plus 2. So minus of 10 plus 2 is minus of 8. For I1, minus of 8 is equal to 0. After taking this minus of 8 to the right hand side, then I1 is equal to 8 divided by 4. So 8 divided by 4 is equal to 4 into 2, that is equal to 8. So 2 ampere is there. So I1 is equal to 2 ampere, and that I1 is equal to I. So I is equal to 2 ampere. So the answer is 2 ampere. Okay. Now see the question number 2. Find the I. So where is I? This is the I. Okay. So we need to find the I. So this is the another network, and this is another network connected with the same ground potential. Okay. So this is 5 voltage sources connected with the 2 ohm resistance, and 2.5 volt here. With the this is voltage source, voltage control, because of VAB is there. Okay, so for VAB, that means it is voltage control, voltage source. Okay, please remember that it is voltage control, voltage source with a 3 ohm resistance and 1 ohm resistance connected across there, or this is the VAB voltage. So we need to find the value of I. So see here, I is equal to, in this network only we are taking in the anti-clockwise direction. It is so minus to plus, going minus to plus direction. So I is equal to voltage divided by total resistance, that is 4 VAB divided by total resistance 3 plus 1. Okay, so because the resistance are connected in the series manner, that why we are adding both the resistance. 3 plus 1 is equal to 4 and 4 ohm is there. So 4 and 4 will be cancel each other. So only VAB is equal to I. So this is our another equation. Now see here in this V dash, this is the V dash voltage across the 1 ohm resistance, and current will be flowing I. So I into 1 is equal to V dash. Okay, so something multiply with the 1, that is something, that only. So V dash is equal to I. Like that, KVL put here in the KVL equation put here. So this is the 2.5 voltage flowing like this in clockwise direction, so that's why we are taking minus 2.5 plus VAB, because of the it is flowing like this, so that's why here positive sign, so we are taking positive signs, positive VAB plus V dash, it is also positive signs, that's why V dash. Okay, so we have already known the VAB value, that is I, put here I, and V dash value is I, so I plus I is 2I. Okay, so 2I is equal to minus of 2.5 and I is equal to 1.25 ampere. So our answer is 1.25 ampere here. So see, every network there we apply the KCL, KVL, or what? The Ohm's law only. Okay, this is our Ohm's law, this is our KVL. Okay, now see the question number 3. See, there is 10 volt with 1 ohm resistance connected with the series, and 5 volt with 1 ohm resistance connected with that series, and in between the two voltage sources, one current sources is there, that is 2 ampere. And please note that when current sources branches is common for two measure, it is possible to find the solution by using the Supermesh technique. So there is a current source, that's why we use the Supermesh technique. So before going to our calculation, I want to discuss the Supermesh in mesh in this short manner. Okay, so see, mesh, that means in mesh analysis we apply only the KVL and Ohm's law, but in Supermesh we apply the KVL, KCL with the help of Ohm's law also. Okay, so please remember that mesh analysis, in case of mesh analysis we apply the KVL and Ohm's law, but in case of the Supermesh we apply the KVL, KCL with the Ohm's law. And another important term, see that in this Supermesh, current sources not considered. Here 2 ampere will be not considered in this Supermesh. Okay, so let find the solution or find the value of I1 and I2. Okay, so first apply the first loop here. We are not considering the 2 ampere, that's why we are taking the outside loop. So minus of 10 volt plus I1 amount of current flowing across the 1 ohm resistance, that's why I1 into 1 plus here I2 amount of current will be flowing across there with the 1 ohm resistance, that's why 1 into I2 plus, because of it is flowing like this clockwise direction, so plus is in the first phase, so 5 volt is there, is equal to 0. So see here, this is the first loop, and we are not considering the 2 ampere current, but now we are taking the KCL equation here. Okay, we are taking the KCL equation here in this branch. So see, there is I2 current and there is I1 current. So I2 current will be like this, so 2 ampere will be flowing like from ground to upper level, from ground to upper level. So that's why I2 current is very much and I1 is very less. That's why I2 minus I1 is equal to 2 ampere. Okay, so I2 minus I1 is equal to 2 ampere. Now put the value after calculating this minus 10 into this I1 plus I2 is equal to 5, because of minus 10 plus 5 is equal to 5, and putting the equation number 1, this is our equation number 1, I2 minus I1 is equal to 2. So put the value of I2. Okay, put the value of I2, that means I2 is equal to 2 plus I1. So 2 plus I1 is put here, I1 plus I1 is 2, I1 plus 2 is equal to 5, then here 2 will be transferred to this side, that is 5 minus 2 is equal to 3, and I1 is equal to 3 by 2, that is equal to 1.5. Okay, so I1 is 1.5, then put the value of I1 in this equation number 1, then we will get I2 is equal to 3.5. So this is your answer, I1 is equal to 1.5 and I2 is equal to 3.5. So do like this more and more problem. Okay, so now see the another question. So it is asking about to develop the mathematical equation for the network sum. This is a very complex network. If you will see, this is the voltage sources V1 with the resistance R1, and this is the current sources with voltage control current sources. Okay, with the parallel R2 resistance, and this is the current sources with the parallel R3 resistance. Okay, see, this is the first network, this is the second network, this is the third network. Okay, our network, that means it is one mesh, second mesh, third mesh. Okay, now put the KVL in the first loop. We are putting the KVL in the loop. Okay, why? Because if we are not considering the IS or this current sources, we are not considering this current sources. So V1 minus of V1 plus I1 R1 plus I2 R2 plus I3 R3 is equal to 0. So this is our equation. This is our super mesh analysis. Okay, so here we will apply only the KCL, KVL and Ohm's law. So now put the KCL in the node A. So this is our node A. So here I1 amount of current will flowing in clockwise direction and I2 will be flowing in the anti-clockwise direction. See, this is flowing like this. Okay, so this is anti-clockwise direction. So here I1 minus I2 is equal to this current, that is Vx divided by 2, and put the KCL in the node B, then you will find I3 minus I1 is equal to Is. Okay, by only applying the KCL. So those are the some problem related to mesh and super mesh analysis. So for today, that's it. Thank you for watching.